Okay, perfect. So as Brittany briefly mentioned, my name is Tristan Hallam, and I'm the laboratory associate at Northwest Mosquito and Vector Control District. And this talk today is primarily going to be concerning vector control practices in Southern California, as well as some of the vectors and vector-borne diseases that we generally are covering. So Northwest Mosquito and Vector Control is identified not only as a special district, but also a public health agency, in that we primarily are dealing with a special public health issue, namely vectors as well as arboviral diseases. Northwest Mosquito is located in Southern Corona, so feel free to come by and visit us anytime you guys want. We cover the cities of Woodcrest, Riverside, Haruta Valley, Eastvale, Norco, Lake Elsinore, as well as aspects of Temescal Valley. Now, we cover approximately 305 square miles with roughly 800,000 citizens encompassing these cities. Now, as a vector control agency, we tend to be on the smaller side with approximately 26 full-time personnel. So you can imagine having 26 personnel servicing 800,000 individuals on a regular basis can get somewhat problematic. So we, as well as every other vector control agency, practices aspects of IPM, or Integrated Pest Management. Now, IPM is defined as the rational decision-making process for the optimal use of resources for vector control. That essentially means we are going to be trying to use our tools as effectively as we possibly can to be servicing our citizens. Now, again, we, as well as other vector control districts, break up our services into 3 separate environments. Oh, we got some chats just in case. Oh, nope, that's not to me. Sorry. We break up our services into 3 separate teams: our surveillance team, abatement crew, as well as our public education department. The surveillance team is primarily concerned with tracking some of these arboviral diseases, collecting abundance information about these mosquitoes, and being able to accurately assess ecological need within specific environments. Our abatement team takes that information from the surveillance department and chooses products specifically depending on the areas that the surveillance team has identified, as well as some of the other issues that we may be encompassing. If we're identifying higher abundance in certain areas or other vector-borne diseases in particular areas, all of this information is going to assess what the abatement team will be using in these specific areas. And finally, the public education department will be collecting the information from the surveillance team as well as the abatement crew in order to create accurate messages that we're trying to permit to the public. We will also take that information and we will summarize it into brief talks like we're having today to try and inform the public of some of these best practices that we're attempting to use, as well as some of the arboviral disease agents that we're regularly are occurring within our district boundaries. Now, I'll be mentioning vectors a number of times. Our surveillance team is monitoring for them, the abatement team is treating them, and the public education department are talking about them. But it's really important to understand what is a vector. Now, when we're talking about biological sources instead of math or some of these other types of vectors, a vector is an organism capable of transmitting disease-causing agents to humans or animals. Or more simply, it's any organism that can impact human and animal health. Now, the image below is what we'd identify as the epidemiological triangle of disease transmission. It describes how a disease-causing agent is able to cause a disease and transmit it to a host who will have some kind of natural defenses against blocking said agent, as well as interacting with the environment that's going to be inhibiting some of the agent's infectability. Now, a vector is going to have a unique location within this triangle in that it's going to be able to transmit the agent directly to the host, overcoming many of the natural inhibitors the host as well as the environment may be playing on it. Now, when we're speaking more directly about vectors, or specifically some of the issues that we deal with at Northwest Mosquito and Vector, we're primarily focusing on the control and abundance locations of mosquitoes, the surveillance of ticks, as well as the exclusion of rodents and mice. And just because these are the focus areas that our district covers doesn't necessarily mean that there aren't other vectors that we need to be concerned about in our diverse ecological environment. Nuisance flies, such as culicoides, are normal vectors of blue tongue as well as leishmaniasis in many parts of the world. True bugs, or kissing bugs, are notorious vectors for Chagas disease in South America. And finally, honeybees are very well known for causing anaphylactic shock in individuals that are allergic to their stings. Just because we're only going to be primarily focusing on these top 3 vectors today doesn't mean that there aren't more areas of topics that you can be looking into if this is something that ends up being interesting to you. But as I mentioned before, we'll start off by talking about mosquitoes, and then near the end we'll touch on ticks as well as rodents and mice, just to conclude the talk. So one of the primary reasons that we tend to focus on mosquitoes very heavily is because not only are they an abundant nuisance pest, but they're also one of our traditional disease carriers when we're considering vectors. As I'm sure you're all aware of, mosquitoes traditionally will take blood meals from a host in order to create eggs in order to propagate their species. When a mosquito takes that blood meal, they'll actually oftentimes be transmitting some kind of a disease agent that otherwise would not have been able to transmit at the same time. We typically refer to that as a vector-borne disease or an arbovirus. Now, much of human history has shifted around the emergence of many of these arthropod-borne diseases, and we as a society rely on vector control practices in order to mitigate these problems, as well as elaborate on many of the public education that is required in order for our citizens to have a general understanding of where these vectors are coming from and how they're affecting our environment. This image below actually is from a PSA the Walt Disney Company produced back in 1943, called the winged scourge. It kind of talks about how the malaria mosquito had been a traditional problem for farmers and agricultural workers back in the day, and it actually uses the 7 dwarves as vector control technicians to kind of show some of our common practices. A great little video if you ever get the time to actually watch it. Now, much of the conversation additionally revolves around mosquitoes, since they have typically been known to be classified as the world's deadliest animal year in and year out. As of 2018, or I guess I should say more specifically in 2018, there were 725,000 mosquito-related deaths, 405 of those directly relating to malaria. Now, when we think about some of our deadly animals, our lions, our tigers, our bears, oh my, we typically don't consider mosquitoes to be in that same category. But when we include in the conversation some of these arboviral diseases that are propagating throughout much of the world, we typically end up seeing this higher death rate when we're trying to control these vectors. Now, as a vector control agency, when we're trying to control some of these significant issues, it's always best to start from the building blocks of some of these vectors. When we're talking about mosquitoes in particular, it's always best to start with the mosquito life cycle. Now, as I'm sure some of you are aware of already, mosquitoes actually rely upon water in order to propagate their life cycle. Mosquitoes are known as a holometabolous insect in that they go through an egg, larval, pupae, and adult stage. So the adults will collect a blood meal, digest said blood, and be able to produce eggs. They'll end up depositing those eggs near or around a water surface, and within a number of days, those eggs will end up hatching into what we can refer to as the larval stage. As the larvae continue to grow within that water source, consuming biological materials and getting larger and larger, they'll go through various instars, and that's how we kind of measure how large and how long some of these larvae have been within certain water sources. After a few days, those larvae will then metamorphosize into this non-feeding pupal stage that typically occurs near the top of the water column. Within a number of days after that pupae has emerged, it will then metamorphosize once again and emerge as a flying adult. We typically like to say that that life cycle, starting from the egg, going all the way through the emergence of a pupae, will take approximately 1 to 2 weeks. Now, afterwards, that adult will continue to persist within the environment, collecting sugar in order to sustain itself, as well as the occasional blood meal in order to produce more eggs and continue its life cycle. We again like to typically say that mosquito adults will be able to sustain themselves within the environment for approximately 2 months. Now, as I mentioned at the start of the slide, mosquitoes rely upon these water sources in order to propagate and begin growing within the environment. But what do we classify as some of these water sources? Can they persist in the ocean? Can they persist in my backyard? Where are we looking to try and find some of these mosquitoes? Well, some of the typical breeding sources that these mosquitoes are able to inhabit are virtually any of these locations that some of these clean or eutrophied water sources are able to persist in. Some of these domestic pools and containers, industrial sumps and tanks, agricultural pastures and horse troughs, to natural wetlands and duck ponds. Just to give you all an idea about what some of our vector control technicians have to go through when they're deciding what products to use, how many mosquitoes are in these areas, just to give you a brief idea about what the choices they must take in order to control some of these specific mosquito sources. So to start off with, we can talk about the Culex tarsalis, or the Western encephalitis mosquito. Now, this mosquito primarily prefers these open and clean water sources, our natural wetlands and dams, but they can also persist within some of these domestic gutters and pools. Regardless of where they're persisting, there tends to be this higher ecological invertebrate species that they tend to interact with on a regular basis. We can compare that information with the Culex stigmatosoma, or the foul water mosquito. Now, this mosquito is going to be preferring some of these industrial sumps, poolings, as well as our agricultural pastures and horse troughs, because they're preferring some of these smaller, closed, eutrophied sources. They're actually really going to be starting off to put off some offensive odors, as well as potentially having some of these other very rich, carbon-rich environments that they're able to be persisting in. Now we can compare that information with the Culex erythrothorax. Similar to our Culex tarsalis, they're able to persist in some of these natural wetlands and duck pond environments, but where these mosquitoes tend to persist more heavily is at the base of these cattails or tule plants. These mosquitoes have been able to create this very specific ecological niche, whereas many of our other species will only be able to breed in the tens to hundreds within these cattail locations. The Culex erythrothorax will be able to breed in the thousands to the 10,000s, just because they've been able to mark out this very specific area that they're able to thrive in very heavily. And now we can compare all of that with our last species, the Culex cuncavaceatus, or the southern house mosquito. Now, I like to consider this species our jack-of-all-trades mosquito, simply because, as you can see, there's no natural preference towards any of these water sources, simply because they're able to equally perform in virtually any of these environments at most times of the year. If the weather is in their favor, and if there happen to be just the right amount of resources for them, they're equally able to persist in virtually all of these environments, making it one of our biggest issues that we need to be concerned about. Now, one of the reasons, again, additionally, that we focus on these 4 species, or more specifically, these Culex mosquitoes as a whole, is because they're very adept at being able to transmit one of our most well-known arboviruses, West Nile virus. Now, West Nile virus is additionally known as a flavivirus. It's similar in structure to many of our other arthropod-borne diseases, such as Zika, dengue, and yellow fever, and its origins date back to the late 1930s in Uganda, Africa. Now, West Nile virus in humans were actually fairly well off. Most of these cases of West Nile virus infections are asymptomatic. So 8 out of 10 of these cases where a human will be infected with West Nile virus, they tend to show no signs or symptoms. And in fact, they may never even know that they had this West Nile virus infection to begin with. Now, what we need to start being concerned with are when these mild symptoms start to occur that involve fever, sometimes our shakes, chills, things of that nature. These 2 out of 10 cases are where we need to be starting to concern ourselves. Where we additionally need to be keeping an eye out for are these rare 1 in 150 cases that tend to develop severe symptoms. Some of these symptoms involve serious nervous damage as well as possible death. We refer to these cases as neuroinvasive West Nile virus infections. Essentially, the virus has been able to invade the central nervous system and is beginning to wreak havoc on some of the neural connections that we're able to make throughout the body. Now, on average, approximately 150 people die throughout the United States every year from West Nile virus. But those infection numbers, especially with those neuroinvasive cases, tend to be much higher. So when we're considering the cost of West Nile virus to our populace, we don't just consider deaths because, as I mentioned, these neuroinvasive cases can wreak devastating effects on some of these individuals where they have to relearn how to walk, how to talk, how to eat, and actually how to interact with their peers. So these are all factors that we need to be considering when we're performing some of these control measures. Now, if we want to be even more specific about West Nile virus, we can think about West Nile virus specifically in California. Now, there are a number of vector control agencies as well as public health agencies that their primary task is dealing with mosquito-borne diseases, simply because California does have the highest amount of known West Nile cases among the continental United States. From 2019, we had approximately 214 human cases in California, and we need to keep in mind that these cases generally are asymptomatic. 8 out of 10 show none of these signs or symptoms. Yet, of these 214 Californian human cases, approximately 143 of them ended up being classified as neuroinvasive, damaging the central nervous system and potentially wreaking more damage to these individuals. What we assume occurs in a lot of these cases is that underreporting or misreporting tends to occur with some of these fevers. They may not be tested for the presence of West Nile virus, or they may not even know some of this is occurring, which is why consistent data entry needs to be occurring within these populations. Now, something to be keeping in mind of when we're talking about West Nile virus is this disparity that we see on a regular basis within the number of human cases that occur on a regular year, as well as the number of positive mosquito samples that we will see throughout the environment. Well, the reason for that magnitudinal difference is that West Nile virus actually doesn't persist very well within humans. The traditional West Nile virus transmission cycle typically occurs between our locally bred mosquito species, as well as some of our bird species as well. This is what we consider our traditional West Nile virus transmission cycle. When a mosquito ends up feeding upon a human, we consider that mosquito to be a bridge vector, and the host, typically are these humans or these horses, to be what we refer to as a dead end host. A dead end host is an organism that is able to collect the virus, show signs or symptoms, become ill from the virus, but not be able to pass it on afterwards. If an uninfected mosquito were to come along and bite a human after they've been infected by West Nile virus, they will not be able to transmit the virus back to that mosquito. Additionally, when we're thinking about the West Nile virus transmission cycle, we can also look at some of our corvid species. An unfortunate biological effect that occurs with many of these crows or these ravens is that once they become infected with West Nile virus, they actually very quickly die off. And we as vector control agencies and other public health departments actually go around and we collect these corpses and we will test them for the presence of West Nile virus, using this as another agent to detect the presence of these arboviral diseases within our district. Another tool that we'll regularly use is that some other bird species, like our egret species, some of our ducks, as well as the occasional chicken species, will be able to collect the virus, propagate it within their body, but they won't show any signs or symptoms, become ill from the virus, or be able to transmit it back to the mosquito. We refer to these species as sentinel species, or more specifically for vector control purposes, sentinel chickens. Now, as I've mentioned, all of these different aspects of monitoring for West Nile virus, as well as being able to control the virus, a lot of this information is stored and collected through a collaboration between the various public health departments throughout California, UC Davis's Arbovirus Research and Training Branch, as well as various mosquito and vector control associations throughout California. This is the westnile.ca.gov website, where you're able to report many dead birds, as well as collect information on local West Nile virus infection rates throughout the county. And as I mentioned previously, we have our information on various human cases, our dead bird species, mosquito samples, sentinel chickens, and horses. These are all various tools that we're able to use to collect information on how much of the virus is propagating throughout our environment that year. And then we can use that data to compare it to other years and be able to get a general idea about what our local ecosystem is telling us about these vectors. Now, oftentimes when we're trying to collect these mosquito sample species, or these positive mosquito samples, we'll be primarily focusing on those QLEX species that I mentioned previously as well. Well, in order to collect those samples, we'll traditionally be using QLEX trapping tools in order to collect those species, pool them together, and be able to test them for the presence of some of these diseases. If we're primarily focusing on abundance of mosquitoes, we will use something referred to as the EVS trap, or the encephalitis vector surveillance trap. This is built together. Oh. That's fun. It's built of a painter's can filled with dry ice that, as it sublimates, it creates a CO2 cloud that is meant to pull in various mosquitoes that are looking to collect some kind of a host meal from that in the nearby area. Once a mosquito is attracted by that CO2 cloud, they'll be pulled in from a battery and battery-powered fan into a collection net where one of our surveillance team members will be able to come by and collect said trap and net to collect information on abundance, as well as mild information on arboviral presence. Now, if we're primarily focusing on trying to collect information on the diseases that may be persisting in the area, we can use something referred to as a gravid trap, or a dirty water downdraft trap. This trap is ideally designed to mimic some of these dirty water sources that some of these mosquitoes may be trying to lay their eggs in. The top of this trap is filled with a dirty water source that is actually very attractive to some of these mosquitoes that are trying to lay their eggs in some of these wetland areas. As the mosquitoes come by and try to lay their eggs in on the water, they'll actually be sucked down into this central column that consists of that same battery pack as well as battery-powered motor and a capsule on the inside in order to collect the mosquitoes and test them afterwards for arboviral presence. Because one of the advantages of testing these gravid mosquitoes is that they actually have a higher arboviral load within their midgut than some of these other species. Now, once our surveillance team collects this information and is able to create various reports, they're able to transmit that information to our abatement team in order to allow them to begin choosing their best practices and decide how they wish to be treating some of these mosquito species. So they'll begin by applying larvicidal applications in order to try and control some of the initial stages of the mosquito growth. Some of the tools that they'll be employing are delayed release briquettes, for some of these closed pool systems that are persisting in the environment longer. Oils or growth regulators, when they identify multiple life stages of the mosquito, the oils will actually create a film on top of these water sources that prevents the mosquitoes from being able to come up through the water column and being able to collect oxygen. So it essentially suffocates them in their own water source, and it's actually very effective in some of these larger water sources. Finally, we'll also be applying granular larvicides in some of these larger open water sources where the mosquitoes may be hungrier. In this case, the pesticide is actually linked with a corn cob fragment that is going to be displaced throughout these wetland environments. The mosquitoes will feed upon these corn cobs, and they'll actually be ingesting much of the product that will actually be ideally killing off much of the population. Now, as a vector control and public health agency, we are primarily trying to focus on preventative practices. Larviciding is said preventative practice to prevent many of these adult mosquitoes from persisting throughout the environment. But when abundance levels get too high and the need adjusts, we will additionally be using adulticidal applications. Some of these aerial bound applications, backpack sprayers, as well as these truck mounted wide area sprays. We can use these in areas that the adult abundance is too high, and we need to be bringing this down in order for our population to be less harassed by these local populations. But again, as I mentioned, as a public health agency, we're primarily trying to focus on proactive measures instead of reactive measures, since these reactive measures tend to be far more expensive and far less effective than many of our proactive larvicidal treatments. If you want to think about it concretely, we're trying to treat a very open air source, trying to come into contact with many of these adult mosquitoes. Whereas many of our larvicidal treatments, we're trying to treat a small water source with a more concentrated burst of these products. It makes more sense for us to be focusing our efforts on larvicidal applications rather than waiting for the issues of these adults and potential disease transmission to be occurring. Now, our last source of control for these Culex species are using biological control agents. Biocontrol is essentially using some of these naturally occurring tools in the environment to be controlling a problem that may be persisting through some of these areas. The tool that we are particularly adept at using is the use of these mosquito fish, or more usually referred to as the Gambusia affinis. Now, these mosquito fish are able to consume approximately 100 mosquito larvae in a single day, but we need to be very careful about how we apply these mosquito fish, simply because they are not only cannibalistic, but they're also predatory on many other fish species. If we were to apply these fish into some of these open water sources, they would actually outcompete many of these other fish, and eventually they would be some of the only organisms of that trophic level persisting throughout the environment. So we not only need to be very careful about how we apply them, but in fact, it has to be in a very controlled manner. Now, up until this point, I've been primarily focusing on tried and true methods of Culex mosquito control that have been around for decades past now. But recently, we've begun seeing some of these new mosquitoes that have been invading Southern California regions, something that we refer to as invasive Aedes mosquitoes. Now, some of you may know these mosquitoes as ankle biters or day-biting mosquitoes, and I'm just going to really quickly go through a couple of these species that we've been seeing in other areas, and then focus on one of our species that we are currently dealing with on a regular basis. So first of all, we have the Aedes albopictus, or the Asian tiger mosquito. I like to consider this mosquito the girl next door. It's a suburban dwelling mosquito with a less preference towards city dwelling. This is a threat on the horizon because various other agencies throughout Southern California have already identified this mosquito and have an idea about how it interacts with their environment. Next, we'll have the Aedes nodoscriptus, or the Australian backyard mosquito. For this mosquito, I like to consider it the new kid on the block. It's a new species that we've only found throughout some of our LA County areas, and we don't really know at this point how it's interacting with the Aedes albopictus as well as other local species that we're currently transmitting and dealing with. Finally, we have our issue, the Aedes aegypti, or the yellow fever mosquito. I consider this species our white whale species. She is elusive, menacing, and dangerous. She's an urban dweller as well as a container breeding, and we've identified this mosquito as an emerging invasive problem. Some of the reasons that this is such a serious issue is that these mosquitoes actually love to be feeding on people. They have evolved some of these natural predilections towards feeding on people over many other animals. Not only that, but they're persistent feeders, and they'll actually be able to track people through the carbon dioxide that we're breathing off on a regular basis and follow them for long periods of times. Not only will they bite around the ankles, but they'll also bite during the day as well as the evening. Very different than some of our normal mosquito species where they're only feeding during these dusk hours. They're biting much more frequently, and they're biting at a higher rate as well. Additionally, they have this aspect where we refer to them as sippers, or they'll take partial blood meals. Again, when we compare them with some of our traditional Culex species, they will take one bite as well as one blood meal. These mosquitoes will bite multiple times, multiple people, in order to collect this blood meal on a safer basis. That increases the risk of arboviral transmission because there's a possibility that one mosquito is biting 6 or 7 people, or you 6 or 7 times in continuation. And finally, we're beginning to see some of these new mosquitoes, they're having these expanded ranges due to some of the effects of climate change that we're recently seeing. As some of these temperatures are increasing and the climate as a whole is beginning to increase in more of our southern border areas, we're seeing some of these tropical mosquito species that typically have only been found around the equator up until this point. Now, the primary reason that we are concerned with trying to control these mosquitoes is because of the invasive Aedes disease transmission cycle. Now, if you will remember what we had talked about during West Nile virus, is that the primary transmission cycle for them was between these mosquitoes as well as these bird species. Well, that's no longer the case with many of these tropical diseases, our dengue, Zika, chikungunya, and yellow fever. Now, these mosquitoes are able to directly transmit it to people, and people are able to readily transmit it back to some of these other mosquitoes. We no longer have an intermediary between this cycle. It's actually directly affecting us. Now, while this does sound alarming, I want to just add a little side note saying that as of this time and throughout most of Southern California, the rate of local transmission for any of these diseases is negligible to none. Throughout Northwest, we've actually never identified an Aedes aegypti that has been able to locally spread any of these diseases throughout any of our areas. We will have something referred to as travel cases. Those are individuals that come from other areas and have ended up testing positive for some of these diseases. But again, to reiterate, we have not identified any of these mosquitoes transmitting these diseases. Now, when we're considering controlling for the Aedes aegypti specifically, we need to consider its biology once again. And one of the difficult aspects of these Aedes species is that they're primarily container breeders. They only need small amounts of water in order to be able to propagate. Now, when we've been traditionally thinking about how to be controlling mosquito sources for breeding, we primarily are focusing on our ponds, these neglected pools, and traditionally some of these fountains and bird baths. But now that we're dealing with these container breeders, we have to be opening up our perspective to many of these smaller sources. Our rot holes in trees, tires, leaky hoses, wagons, toys, water bowls, pets, virtually anything that can hold up to 1 to 2 milliliters of water are able now to be potential breeding sources for these mosquitoes. So as our control measures and our surveillance evolves, we need to be using different tools in order to be identifying what the abundance levels of these mosquitoes are like throughout our environment. So some of our 80 surveillance tools include our into care treatment and surveillance trap. I'm going to be talking about this a little bit more later, but for now, just understand it as a bucket with a small amount of water in the basin that's able to attract mosquitoes, allow them to lay their eggs in it, and when we can get an idea about larval abundance based on those eggs. Additionally, we will use BG Sentinel-2 traps. These are ideally mimicking some of these containers that these 80 species will be trying to lay their eggs in and be resting on throughout the environment. Again, similar to our gravid trap, the Aedes mosquito will be flying by, begin inspecting this container as if it's trying to lay its eggs on it, and get sucked down into the central column where a net is awaiting it, and some of our surveillance team is then able to come, collect said trap and net, and get an idea about abundance as well as the potential for disease transmission. Now again, similar to our QLEX surveillance tools, the surveillance team will take that information and transmit it back to our abatement team in order for them to start developing accurate control measures. Again, using that aspect of IPM, or our integrated pest management. So depending on the source as well as what is in the area, we'll primarily focus on larval source reduction, spray applications, into care treatment, as well as employing public education. So depending on the sources that we have found, we may start with using source reduction. And that essentially means we'll start finding each and every container throughout a neighborhood or a yard or what have you, and begin dumping the water. That's all it involves. Find the water, dump the water. Now, this can be labor intensive and it can be expensive due to the amount of labor that sometimes can persist throughout this problem. As you can see in this lower left-hand image, I always love to be using a toilet as an example. No matter which way you turn a toilet, there's always going to be some aspect of it that's going to be holding water. And no matter what, that amount of water is going to be enough to be breeding Aedes. So when we're choosing source reduction or some of these other tools as control measures, we need to be keeping that in mind for how best we're going to be able to control these larvae. Additionally, we could focus on larval spray applications. This is, again, using some of those backpack sprayers so that we can disperse these larvicidal droplets out to many of these larval sources. If there are just far too many containers, then these droplets can actually infect many of these water sources and cause them to be uninhabitable for many of these larval species. And many papers have actually found this type of application to be more efficient than source reduction and far cheaper. So depending on the source and depending on the size of the location, this may be something that we're more likely to be using. Now, going back to our into care control, not only is it a basin that is having a small amount of water held underneath it, it actually contains a dual acting pesticide as well. It contains a fungal infection as well as a product called pyroproxyfen. When one of these mosquitoes ends up coming by this larval source to try and deposit eggs, they'll actually take up some of that pyroproxyfen upon its body, and as it's going to additional containers, it will be dropping off small amounts of this product in order to contaminate more of these locations that this mosquito may be depositing eggs in, thus making those sources invalid. Then, within a few days after propagating the pyroproxyfen, the adult mosquito will actually end up dying from that fungal agent. This is a new control method that we're investigating and using in a few small areas, but we're also starting to see some really positive feedback and control measures from just using these small buckets. And finally, we'll collect all that information. We'll take essentially everything that we've been doing up until now, as well as information from other agencies, and we'll perform outreach and education. Again, we'll have conversations like I'm having today with you all, and then we'll be producing flyers and pamphlets in order to get that message across. And not only will we be creating one or two, we'll be creating flyer after data sheet, after infographic, after back translated flyer, after additional data sheet. Because the idea is to inundate the public with this message multiple times in various platforms in order to get these ideas of vector control across to the individuals that are needing them. So in conclusion, for the mosquito portion is to just continuously be on the lookout for some of these day-biting mosquitoes. It is a public health risk, and it's something that's going to be persisting through our environment for the foreseeable future. So it's something that as our strategies evolve with, the public is going to need to be evolving with us in order to be able to manage some of these new pests. Now, while we do primarily focus on mosquitoes as vectors, again, throughout Northwest especially, we're also concerned with some of these tick-borne diseases that may be transmitting throughout the environment, as well as keeping our public safe from rodents and mice. So really briefly, I'm going to touch upon these two subjects just to give you essentially a 101 of what you need to know about these various vectors. So ticks, similar to mosquitoes, come in various sizes, as well as various life stages. They'll begin as an egg, go through a larval, a nymph, as well as an adult stage. And these stages actually rely on some of these hosts that these ticks are actually feeding on. The eggs tend to be laid nearby some kind of a host species nest. Once those eggs hatch, the larvae end up attaching to that first host, and then they'll molt into their first nymphal stage. Once they've molted, those nymphs typically will begin trying to feed on a larger source and eventually be able to molt into an adult afterwards. Once those adults have then successfully molted and begun to hunt for a new host, they'll collect an additional blood meal and then begin producing eggs. Again, each of these life stages for these ticks determines what kind of a host will be feeding on it, which is typically why when we will ever see a tick on us, 99.9% of the time, it's going to be these adult species because they're the only ones that are going to be going after these larger mammal sources. Now, I'm careful to say larger mammal sources because ticks only feed on humans as accidental or chance hosts. As you can see throughout the infographic, humans don't persist necessarily anywhere directly on this chart because we only find them on ourselves as some of these accidental hosts. But if we're going to be accidents for these ticks, then where are we collecting them? Where are they persisting? So typically, whenever we're going out on these woodland hikes with this low abundance of grass and vegetation, that's really where we're going to be finding some of these tick species. The way that they're actually attached to us is that they will begin to climb up along these small grass stalks, and they'll reach out their tiny little arms as far as they can. And at the end of these arms, they have these miniature hooks that as various mammals or humans come by and actually brush up against some of this vegetation, the ticks will grab on and begin climbing up and around the host in order to try and attach their mouth parts to begin collecting some semblance of a blood meal. Now, when a tick does attach to a host, we need to be very careful about what we do about it because these tick mouth parts are actually serrated like these tiny little knives, and they're very easily able to embed themselves within the skin. So when people come to talk to us about, oh, I have a tick bite, oh, I think a tick is attached to me, we always have a very specific measure of how to remove that tick from the person. What we typically try to recommend is using these pairs of forceps or tweezers to grab the very base of where the tick is attached to the host and to be in one quick motion pulling directly away from the skin in order to not only collect the entirety of the tick, but the entirety of the mouth parts as well. Oftentimes, if we're using some of these other methods to remove the tick from the host, these mouth parts will actually break off within the host. And if there are any disease-carrying agents within the tick, they'll actually be left in the skin, increasing the possibility of disease transmission to the host. Now, if we're trying to prevent some of these ticks from actually attaching to us, or if we're going out into these woodland environments anyways, there are some steps that we can take in order to prevent these ticks from attaching. So some personal protection steps that we can take is simply tucking in our clothes to our pants or socks, and we create fewer access points for these ticks to be able to actually attach to our persons. Anytime I go out in the environment, I'm going to look like a real cool guy, and I'm going to be tucking my pants into my socks, as well as making sure my shirt is always tucked into most of. I'm creating as few access points for these ticks so that I'm not going to be having some kind of a surprise later on that evening when I'm taking a shower. Additionally, we'll typically try to recommend applying some kind of personal protective spray directly to clothes, but, and I'm going to reiterate this once or twice, but to follow the instructions on the products. Now, as I'm sure of you are all aware of at this point, but whenever we're dealing with pesticides here as well, we're always recommended to be reading the label. Well, I have a hard time not recommending the same whenever we're using some of these personal protective materials. Even if it's something that you're well aware of and you've been using for years on end, it never hurts to reacquaint yourself with the label. Because, as again, I'm sure you're already aware of, the active ingredients in some of these products can vary depending on what you're using. These images were just taken from the same product used within a few years of themselves. And as you can see, the percentage of the active ingredient drastically changed. And what occurred because of that is how it's applied to yourself. It was drastically remedied. Rather than recommending applying it directly to the skin, they highly recommended only applying it to the base of your clothes and to be keeping it away from your skin. So again, heavily dependent upon what you're using and where you're using it. You need to be aware of what you're using. And again, I'll reiterate it, I'll be happy to be a broken record. Reading the label is never a bad idea. Now, finally, we'll touch on a little bit of rodents now. So throughout the Northwest District, we're primarily dealing with two different rodent species, our roof rat, or the Rattus rattus, as well as the Norwegian rat, the Rattus norvegicus. Now, these are higher level of biological species, so naturally, we're going to see far more of these vector-borne diseases that they're able to transmit. Now, before I get into any of this, I want to leave one more caveat. Throughout the Northwest area, while we do have various rodent species that are pests to our populace, we have not identified any of these diseases being transmitted to humans or even persisting in rodents. Okay, so the way that these rodents will typically be transmitting some of these diseases, such as our Lyme disease, our tularemia, or as many of us are already well aware of, the traditional plague, is through some of these bites, their feces, as well as dried urine. That urine will actually aerosolize, and actually it'll become a breathable agent. That's the primary way that hantavirus is actually able to be transmitted to many individuals. They'll have rodents feeding within some of their cupboards, kitchens, backyards, you name it. And before that virus has had the opportunity to deplete throughout the environment, a human comes in contact with it and actually becomes seriously ill from some of these agents. But as I mentioned, we're primarily not concerned with many of these disease-causing agents because we've not found them throughout the environment. What we're primarily concerned with is them acting as a nuisance pest to many of our residents. They'll readily damage homes, be leaving trace amounts of urine and feces throughout various locations. They're a massive pest upon our citrus populations that exist near UCR as well as on private land. And finally, they'll be damaging a lot of these personal home fixtures that many residents value far more above these rodent populations. So what we always try to recommend to our residents is some aspects of how to be getting rid of them. We always recommend as a first precaution is, do you have any tree limbs that are attached or reaching onto the tops of your houses? If you do, these are the perfect access points for these rodents to be climbing on to the tops of these roofs and gaining access to your house. We always like to begin recommending tree trimming as a primary measure to stop these rodents from getting into your location. Secondarily, we'll recommend trying to remove food and water sources nearby your location. If there's no food and water for these rodents to be able to accumulate, then they'll have no interest in your location. Again, primarily we're focusing on exclusion for the majority of these rodents. We live in an ecologically diverse environment, and some of these predatory species rely on rodents in order to continue surviving throughout these locations. So while we will offer some control methods, we're primarily focusing on trying to keep you safe from these rodents and these rodents uninterested in you. And as I mentioned, in extreme cases, we do have some kinds of control measures to decrease the populations of these rodents. We are able to deploy bait stations that contain generalist poisons that are able to actually control many of these rodent species. Now, we use these with caution simply because these are generalist poisons, and some studies have shown that various coyote species actually end up having these poisons within their gut from consuming dead rodents or other accidental pests that may be feeding upon this poison. Also, as I said, as a generalist poison, pets are a serious issue that we're consistently trying to make sure that we're not inoculating them as well. So as a whole, I just want to say in conclusion that vectors are a wide-reaching aspect of our population and affect many aspects of our lives. Many of these diseases are a public health issue, so we generally ask the public for some assistance. If we don't necessarily know that an issue is in some of these areas, the best help that we can always have is an educated populace. Now that you all know about some of the issues that we face, it's always a welcome hand to be hearing from some of our local citizens and letting us know about what we can do to best help them. And finally, vector control is a continuously evolving field study. As we're seeing with some of these 80s species that are continuously growing throughout some of our Southern California regions, we're identifying new strategies and new control methods that we're trying to be using and finding various levels of effect for many of these new emerging vector issues. So again, here's the contact info for the district. We are again a public health agency, so we're primarily interested in helping you as much as we can. We're always interested to hear about what kind of new insects or pests that may be persisting throughout various locations. And if there's any ever serious types of threat, please let us know. We're always more than happy to help. And with that, I'll thank you all for being such a lovely audience, and I'll open the floor to some questions.